We're going to go over unit vectors, component form of a vector, and the magnitude and direction angle of a vector. All right, so here's the first one, unit vectors. What is a unit vector? So most of the time for a unit vector, we use the letter U for a unit. It is still a vector, but most of the time we'll start, whenever it's a U, it's because it's most of the time it's talking about a unit vector. And what does it mean by a unit vector? Well, what does it mean by what it's a unit vector? I'll give you the formula for it. It is whatever the vector is divided by the magnitude of the vector, is it? So it's whatever the vector is, and you just divide it by whatever the magnitude of the vector is. A vector pointing in the same direction as V, as vector V, but with the magnitude length of 1. Let's do an example. We'll just so problem 1 is saying find a unit vector in the direction of the given vector. So you got this vector with components. On the x is going 3, and then on the y is going up 4. So if I was to draw the vector, this vector here, it's going like this. Over to the right, 1, 2, 3, and then it's going up 1, 2, 3, 4, and so this is the vector here. So now it's saying, well, the length of this vector is actually 5. Yeah, the length of the vector is 5 because it's a 3, 4, 5 triangle. So the length of this is 5. But we want a unit vector where the length is 1. So I want something that is going in the same direction as this one, but with the length of 1. With the length of 1. So what are the components? What are the components of it? So yeah, what would be the components of it? How much is this x and how much is this y? Well, like I could even go off of what I'm just visually looking at this. I'm already telling you that this is 3, because that's what it's saying, it's 3. And it's telling you that this is 4. How can I figure out what are the components of that vector, of this vector? Anybody? Let me see if anybody could just see it, just by looking at it. What would be this length and what would be this? Huh? They're similar triangles. You could just go off of just similar triangles. This baby little triangle, that's a little baby triangle. All of this triangle, they're similar triangles. So what do you think are the dimensions here? What is this and what is this? 3/5 and 4/5 is correct. Why is it 3/5 and 4/5? Because if I divide this by 5, 5 divided by 5 will give me this one. And then if I divide that by 5, I divide this by 5, this will be 4/5. And if I divide this, everything by 5, then this can be 3/5. And the answer is 3/5 without doing any work. That's just by thinking about it. But there is a way of doing it. And the way to do it is this. All right, so let's do it like that. All right. So it says to find the unit vector in direction of a given vector. We need to find the components of the vector. So we already know that the vector, so this is vector V. Let me put it here. This is vector V. That's this. I need to find the magnitude of the vector. Okay, so let's find the magnitude of the vector. So the magnitude of the vector is going to be that formula. What was that formula? X squared, I think it was, plus y squared. Square root of x squared plus y squared. So this is going to be, what's x? What's x? 3. And what is y? This is y, no? Yes? X and y. So we're going to go what? 4 squared. So this is going to be square root of 3 squared is 9 plus 16. 9 plus 16 is what? 25. Square root of 25. And what is the square root of 25? 5. So all you're doing is dividing this by the magnitude of the vector. So one way to do it is to find a unit vector is either to divide by 5 or multiply it by 1/5 of it, because you're dividing by 5, no? So you got what? Vector v divided by the magnitude of the vector. So basically it's going to be 1 over the magnitude of the vector, 1 over 5. So I'm going to go ahead and do 1/5. 1/5 of 3/4, 3 and then 4, 3. And then you distribute that. Or you could have literally, we'll go straight and divided each by 5, which, I mean, that's just what it is, no? It'll be 3/5. So it's going to be 3/5. And this is going to be 4/5. We already did 3/5, 4/5. Let's see. Look. So you need to find the vector. You multiply by 1 over the magnitude, and it turns out to be 3/5 and 4/5. Let me give you a fun one to do. So in this one, we are just going to 1/4. So if you got one graph, you write it. So let's say this is 1 here and this is 1 here. And the graph is going 1/4. This is a half. So this is going to be 1/4. And then up 2/3. So 1/3, 2/3. So it's right here. So there's the vector. This vector is this, but we want it to be a unit of 1. I don't even know what the length of this vector is. So we just gonna go through this procedure. We need to find the magnitude of the vector, and the magnitude of the vector is this formula. So what is 1/4 squared? We don't have calculators. What is it? 1/16? 1/16 is correct. 1/16 plus what? 4/9. You said 4/9. We need a common denominator. So what is the least common multiple? What's the smallest number that 16 and 9 go into? Let's do it this way. I don't even know what it is. Let's just go ahead and put this one needs a what? This one needs a 9 and a 9. And what does that one need? To have a common denominator. 16 and 16. That's basically the easiest way. That's fine. I don't even know what the least common multiple is. Maybe that is or it's not. I don't know. But that's going to give us some. So then this is going to turn out to be 9 over what's 16 times 9? Is it 144? Is it 144? Yeah, I think it is 144. 144 plus 64 over 144. So that's going to be 73 over 144. We cannot take a square root of the top, but we can take square root of 144. What is the square root of 144? So we're going to have square root of 73 over 12. Okay, so there it is. Square root of 73 over 12 is the magnitude of the vector. And so let's go. It was square root of 73 over 12. Okay. So each one of the components of the vector gets divided by this thing here. We could do it that way. So what we're going to have is this. We have 1/4. And then we got 2/3. And each one of them is divided by, is being divided by square root of 73. That's another way of looking at it, or you can multiply it. Square root of 73 over 12. Did I put 73? 73. And then this is going to be square root of 73 over 12. So this is what? A fraction divided by a fraction? So let me do this on the side so you just kind of understand. 1/4 is being divided by square root of 73 over 12. It goes back to elementary school. How do you do that? I don't know if you learned it. What'd you say? Keep the first, flip the second, multiply. It's going to be what? 1/4 times up what? 12 over square root of 73. Square root of 73. Then you can go ahead and divide 4 into 12. So it's going to be what? 3 over what? Square root of 73. How can we do this easier? How can we do? I don't know how. It's a fraction divided by a fraction. I'm gonna bring this to the top, so it's gonna go over here, okay? Then I have what? 12 divided by 4 is what? 3 over square root of 73. Yes or no? You do it whichever way you want to do it, okay? So what did it turn out to be? Square root of 73 over what? Did I say 3 over 3 over square root of 73? So whenever you have a fraction divided by a fraction, let's go. 12 is going to go to the top. What is 2 times 20? 2 times 12. And what's 24 divided by 3? 8. Is that good? Yes or no? Yes, when you do have a fraction divided by a fraction in this particular situation divided by a fraction, then this one denominator may go to the top, and then if they do actually multiply out and then divide it, yes, this is fine. I don't know, you come up with that. Let's see, we get this. Or another way of looking at it, 1 over, then this goes to the top, and whichever way you want to do it, but it turns out to be the same answer right there. Is it? It is, no? That's when dealing with fractions of these things. Okay, move on. Let's move on to the next section. component form of a vector given the magnitude and direction angle. Ooh, we do need a calculator. I think we do need to get a calculator. Let's see. Find a component form of the vector v. All basically it's saying is that if you do know the magnitude of the vector, so say some vector is going like this, and you know that the vector, the magnitude of it is some square root of 73 or something. That's the magnitude of the vector. And to find, if you all you know is this, and you want to find what are the components for of the vector, you actually do need to find the angle or know the angle as well. So you need to know what this angle is. What is this angle? So if you do know the angle and the magnitude of the vector, then you can go ahead and find the components of the vector, the x and the y. And that's by using this. So you need this and you need the angle. So say it was 30 degrees or something, then you can, if you need these two information. All right, but you do need a calculator. Yes, we do. So I will give you a calculator. Calculator. Oh, sorry. Let's get some back down here. It's pretty straightforward. You got the formula. All you do is the magnitude in this situation is 25. This is the magnitude, and you got the angle here, theta. So you got both of that you need to find the x component. You just multiply the 25 times cosine. This is cosine, and then this is sine. So make sure it's in degrees. So all you gotta do is 25 cosine of 42 times cosine of 42. And what does it say about? To a nearest tenth. I think that's what I have around it. What is it? Come on, get your calculators. What is it? Somebody. $25 times cosine 42. 18.6? 18.6? Easy. So this is 18.6 about, and then what is this? $16.7. So this is 16.7, 18.6, 16.7. Next. Yeah, this is a good question. Let's see. Let's do B. So the components of this vector is going to be 6 cos of what? Cosine of what? Cosine of what? Somebody. cosine of what? One what? They're just giving you, they're telling you that from here to here is 15, but you're always going to go like this. So cosine of what? $195. Cosine of 195. 6 sine of 195. What the heck? Yeah, it makes sense. Yes, it makes sense. What are you getting? What are you guys getting? Negative 5.8. Negative 5.8. Does it make sense that it would be, because this is going to the left? So it's negative 1, negative 2, negative 3, negative 4, negative 5, and it makes sense. So this also better be what? Negative, no? Because it's under. So we're going to do what? 6 sine. Oh man, I'm still laughing at who this is. Negative 1.6? Is it 1.6? Alright. Yeah, it's the same of this. It's gonna be what? 5 cosine 235. 5 times cosine 235. What's 5 times cosine 235? That'll be the component, x component. 235. So it's negative 2.9, and then negative 4.1. I'm gonna skip this already. It's kind of redundant. Let's go on next. Oh, well, the minute I say that, this one comes on. So if we are going to use these, if we are going to use this calculator, you better make sure you change it to rads, no? Or you're going to get it wrong. So go to change it from degrees to rads. You're at the very top. We'll change it to radians. And we're going to do square root of 13 times cos 4 pi divided by 3. Error! Oh, I got error. What the heck? There you go. Square root of 13. What the heck? Stop. Clear. Square root of 13. What? What are you doing? Stupid memory? How do you get rid of this memory? Square root of 13. Okay, I got it now. Square root of 13 times. It went back to degrees. Stupid calculator. Rad. Square root of 13 times cos. What the heck? I'm getting error again. What do you guys, is it just me getting error? What did you guys get? Loud. Let me see. Am I not putting parentheses or something? What am I doing wrong? Square root of? What? No, not the answer. Square root of 13. Square root of 13. Close it. Maybe I need to close it. Times it. Cosine 4 pi divided by 13. By 3, not 13. Wow, my head hurts. Negative 1.8. Okay, I finally I did get it right. So you guys learn how to use the calculator. Let's go. Let's finish number 3. I hope this is it. So these are the formulas you need. It's repetitive here. The magnitude is this. It's like the distance formula as well. Is the Pythagorean theorem solved for for the hypotenuse or something. And then to find the angle between, or the angle of the vector and the x-axis, positive x-axis. Redundant. So let's say this vector is v. Square root -3 squared plus 7 squared, and it's going to be magnitude of the vector, square root 9 plus 49, square root of 58. There's no, I think this is it right there, square root of 58. The angle of the vector, that's nu. Theta is going to equal to tangent inverse x over y. What? I think it's y over x. Did I do this wrong? Do I have it wrong? What's tangent? What's tangent of an angle? Isn't it y over x? So you have like something, you got something like this. Isn't it like this? Isn't it opposite? Isn't it tangent? It's opposite. So katoa? Yes? Don't tell me I've had this for forever like this wrong. That's wrong. Wow. That's wrong. It's y over x. Anyway, so it's going to be y over x. So what is that going to be? What? 7 over what? Tangent inverse of 7 over -3. So go back to degrees. Let's have it in degrees. Yep, it's in degrees. And then you're going to do tangent inverse. So you're going to go to tangent inverse, second tangent inverse of, you could put -7 over 3, it doesn't matter. Put -7, it's either the top or the bottom. -7 divided by 3, close it. And the answer is what? Ooh, I'm getting this. What are you getting? -66? Let's round it to a whole number just for this. So it's saying that it is negative. You know what? That should be okay, no? It's -66 degrees. 67, -67 degrees. -67 degrees. Yeah. So you could say that's -70 is -67 degrees. Is that direction? Does it make sense? Now let me ask you. Does it make sense? No, it does not. Okay, look. Why does it not make sense? Because what am I supposed to do? Say I'm here. This vector is here. Which way am I going to go first? If I'm going to do this, which way? Back, left 3, no? Yes? Then I'm supposed to do what? Up 7, no? Let's see. What's the problem here, guys? What is the problem? What is the problem? What are we going to do? Watch. This is the angle we want. This is the angle we want. You know which angle are you getting? Stupid. Make it as an absolute. Let's say, let's make it as, you're going to have problems with this stuff because you really got to understand what would be the answer to this. And this one saying that it's going back 3, up 7, it looks to be something like 90 something and something more. So this, let's take this to be an absolute of 67. So if this is 67, then as an absolute, then you subtract that from 180 because this thing is 180. Yes or no? You're going to have to do a little more thinking. So what is 180 minus 67? Huh? Yes. Yes or no? You guys understand this? It doesn't just spit out an answer. You have to really think about it and understand how this all works. Yes? And where would the vector be at? And what makes more sense? So the answer would be 113. See, I don't even know how long I had this wrong like this. What the heck is that, man? Hold on. All right. So it's 113. Good. Let's do one more. Let's do B. After a while, you should be able to do this quickly in your head. This, you could just kind of go, the magnitude of this particular vector for some of these is going to be square root of what? Negative 2 squared is 4 plus 9, and it's going to be square root of 13. So the magnitude of a vector is square root of 13. And then we're going to do the tangent inverse for the angle. Tangent inverse of negative 3 over negative 2. What's a negative divided by a negative is a positive. So tangent inverse of 3 over 2. What are you getting? About? $56? So let's say, okay, hold on. One more time. This right here, that's wrong again. Why? Because if it's just always put at the origin. So you're gonna go down left 2, down 1, 2, 3. This is definitely not 56. What are we gonna do? So if this maybe is saying is 56, it's saying that this is 56. Hold on here a second. Yeah. So if this is 56 degrees, because it is 56 degrees, that makes that this 56 degree is this 56 degrees because of vertical angles are congruent or whatever. You guys use geometry? You guys use geometry? Whenever you got two lines going like this angle is the same as this angle, no? So if this is 56, because that's what we did get, 56 is this angle. We don't want that. We want this is 56. And so if this is 56 and this is 180, 180 plus 56. Precise, please. So what's 180 plus 56? Yeah, is it 236? Oh, we're done. Good.